Hi, my name is Chelsey Kratochwill, and I'm a database technician in Dr. Van Woofsik's lab. Today, I'm going to give you guys a bit of a background on databases and access. The most important thing when looking at data is to understand what your research question is. For example, I might be interested on the effects of temperature on hard coral cover on a global scale. I need to know what data is available to me, and looking at unorganized data in Excel can be very overwhelming. Looking at a few variables over 20 sites might be doable, but once you have many variables over thousands of sites, you will need more organization. This is where a database and access comes in. Large data sets might have many relationships, and databases help you organize your data logically based on those relationships. And it also allows you to quickly ask questions of your data using queries, which is something I'll explain in just a little bit. The tool that I like to use to manipulate databases is called Access. Access is a relational database management system that can be used in concert with Excel. You can upload spreadsheets from Excel into Access and export tables and queries from Access into Excel. The main parts that make up databases are tables, primary keys, relationships, and queries. Access uses tables instead of spreadsheets to store data about a particular subject. You can break up spreadsheets into multiple tables depending on the relationships that you form. Data in one table can be related to data in another table. These relationships help you combine data from two tables. You can easily connect these two tables by using primary keys. Primary keys are a field or set of fields with values that are unique throughout a table. A query is essentially a question you are asking your data. You supply instructions that retrieve data from one or more tables and then display that data. Queries use SQL or SQL, which is known as structured query language, to ask these questions. There are several different types of queries that can display related data, queries that can update records and delete records, and queries that can make new tables from data in existing tables. There are several differences from Excel. In Access, we use fields instead of columns, and a row is referred to as a record, which contains all the related information across the different fields. There are two ways to look at a table in Access: the datasheet view and the design view. The datasheet view will look very similar to how you're used to seeing data displayed in Excel. The design view allows you to see each field and what type of data it contains. Each field in a record combines to make up a unique ID number. Some people like to create their own unique IDs when they're out in the field collecting data, but they're not always unique, as you can see here in iRef ID. It is better to let Access auto-generate an ID number for each row to ensure that they are truly unique. You'll use primary keys to set up relationships with other tables. In the relationships view, you can see each table in the database. You can see the name of each table and all of the fields it contains. Relationships show the connections from one table's primary key to another's. In this database, the sample event table is the main table that every other table needs to connect to. The sample event table contains all of the location information, dates, depths, and any errors associated with a single sampling event. Every other table will have a sample ID number as a field so that it can be traced back to its location, date, and depth. This allows for a more streamlined view, and because I have a sample ID, I don't need to store all of the sample information in every table. This eliminates redundancy among related tables, and I can look at the coral cover data in my coral cover table and find that sample ID number 35, go back to my sample event table and find out the location info, the date, and the depth of that sample. To help answer the research question I posed earlier, I can ask questions of my data. In this case, I'll be running a select query. Using the select query, I will only add the tables that have the data that I am interested in. I can also select which fields I am interested in by double-clicking on the field name. It'll populate each field down at the bottom. Since I'm only interested in hard coral cover for each site, I can restrict access to only show that information by typing it in the criteria section under the substrate type field. This criteria must match exactly. If there are any missings or misspellings, it will not show any data in the datasheet view. I'm also interested in the temperatures of each site, so I will select temperature information from the environmental table as well. When I'm satisfied with the design, I will run the query to view it in datasheet view. I can now see all of the fields that I selected, and they are displayed. The ID on the end is the sample ID. The query has only displayed all of the hard coral information as I requested. Now I can see every sampling event where hard coral cover data was collected and the temperatures that correspond with each sampling event. I can now export this query into Excel, which will give me a spreadsheet of all of the data that I need to run the statistics in R. There are some weaknesses of Access. There are data size limitations. It struggles with tables that are 2 gigabytes and larger, though these data size capabilities are much better than what Excel has. There's a strict learning curve. It can be difficult for new users. It looks like Excel, but it functions a lot differently. And unfortunately, it is also not available on Macs. Access is widely popular. It's free with the Microsoft suite, which makes it very popular. Um, it has a nice user interface, so you don't need a programming background to use it. It allows you to visualize all of your data and how they are related nicely. It also helps reduce errors by linking related tables. This enforces something called referential integrity, which means if you delete or update a record, it will cascade update or delete across all of the related tables. This way you won't have superfluous or meaningless records floating around. RStudio also has a connections window that allows you to access your tables so that you can visualize them and manipulate them R. And there's also a package called RSQLite, which will allow you to run queries on a database in R instead of running them in Access. I'll now do a live demonstration of what running a query will look like for you guys.